So let's have another example here. A block of mass m is 2.0 kilograms. This block is dropped onto a spring of spring constant. K is 1,960 newtons per meter. The block was initially at a height of 40 cm from the spring's equilibrium position. Find the maximum compression of the spring. Okay, so that's what we want, the maximum compression of the spring. This is really an interesting problem because makakita nyo, oh, ito pala yung sinasabi ni Sir sa diagnostic exam niya. Okay, makita, this is reminiscent of our diagnostic exam. Okay, why? You'll see when I solve the problem. Okay. Okay, so let me first write the solution, the given quantities. The mass of the block is about 2.0 kilograms, and then the spring constant K is 1,960 newtons per meter, and then the height is 40 cm. Ingat sa units, this is about 0.4 meters. Ingat sa units ha, baka malito kayo. And then, ang tinatanong is what is the maximum compression of the spring? So, what are the two states in the system? Okay, what are the two states? The first state is what?
Nasa taas.
Yes, the block is at some height. So drawing ko na lang. So this is the block. Di ko na-drawing na ganyang shape. Block na lang yan. Tapos, meron akong spring. Meron akong platform. Then I have a spring there. Tapos meron akong final platform there. So I will set this to be my y equals 0. There's a reason why I set it that way. So this is y equals 0. Now, the second state, state 2, is this. So, mangyayari, the block will fall down the platform and it will compress the spring, right? With some, let's say x. So, let x be the compression, the spring compression, the maximum compression. So, anong itsura niya? Wait lang. Baba ko na lang to. There's a reason ba't ko binabayan. So this is the base. Okay, ganyan. Tapos ito yung spring. Siyempre, makakompress yan by some x. Tapos, ang mangyayari, magkakaroon ako ng height difference dito na x. This is the original position of the platform. Ito na yung final position niya. Ito yung box. Okay? Therefore, ano mangyayari dyan? Ano mangyayari? So, if this is my y equals 0, so, at the second state, meron ba siyang kinetic energy? Meron ba siyang kinetic energy?
None, sir.
Wala. Meron ba siyang elastic potential energy?
Yes, sir.
Of course, meron. Nag-compress yung spring eh. Ito yung importanteng tanong. Meron ba siyang potential energy?
Sir, wala. Ay, sir, meron.
Meron.
Pero negative.
It becomes negative. It should be some negative mg times the compression of the spring. That is the crucial part of this problem. Okay? Merong potential energy yan because we set our y equals 0 to be at the platform, at the original position of the platform before the collision of the box and the spring. Okay? Nakuha? Gets ba? Gets yung nangyayari? I hope you get it. Okay, so initially, wala rin kinetic energy, so we don't need to include the kinetic energy in our equations. Therefore, E1 equals E2, since there are no non-conservative forces acting on the system, we just write E1 equals E2 here. When I do the calculation, I have an mgy1 plus 1/2 k x1 squared equals mgy2 plus 1/2 k x2 squared. Okay? And at the initial height, let's say y1 is there's some initial y1. But what can we say about the initial elastic potential energy? Ano masasabi natin dyan?
0.
0 din yan. Therefore, because hindi naman nag-interact yung box sa spring, this should be 0. And therefore, I have an mg y1 equals mg y2 plus 1/2 k x2 squared. Now, again, as I said, the compression of the spring is x, and I'll say that, okay, I have an mg y1 equals mg x plus 1/2 k x squared. Okay? And if I transfer this to the other side of the equation, I get something like a 1/2 k x squared plus mg. Instead of having this positive, I'll write this as negative to indicate the direction. Anong difference? Sa annotated lecture slides, ginawa niyang positive to. Ginawa niya positive to. And then, what the slides determined is or I should say, yung writer ng annotated lecture slides, ang hinanap niya ay yung x such that it is negative. Dito, gagawin ko baliktad. Maglalagay ako ng negative sign here, but I will determine an x that is positive. So I will only determine the distance, not the direction, which is now indicated by that negative sign. Okay? Clear? Clear ba yun? I hope this is clear. So, kaya may negative dyan. So, I have 1 of kx squared minus mgx minus mgy1 equals 0. Again, we want to determine x. So, find x. Pero paano hanapin yung x na ganyan?
Sir, gawing quadratic.
It is a quadratic equation, right? Ito yung sinasabi kong importante sa diagnostic exam. Na sinasabi ko at the start of the class, at the start of the semester, wherein this looks like a quadratic equation. It always comes out in energy-related problems. Ito na yun. Okay? And we know the solution for a quadratic equation. We just know that it is the quadratic formula, and hence, using the quadratic formula, we see that x is just equal to what? So this is negative b. Let's say this is a, this is b, and this is c. And we say that, okay, I have a negative b, so I have positive mg, plus or minus b squared, mg quantity squared, minus 4 times a, 1 of k, times c, minus mg y1, all raised to 1/2, divided by 2a, twice of 1/2 k. Okay? Now, alternatively, what you can do is to substitute all the numerical values and just use your calculator in determining x. And when you simplify it, ang lalabas dyan ay, this will give you, x is simply, sulat ko muna yung final form nito, mg plus or minus an mg quantity squared plus 2k mg y1 raised to 1/2 all over k. So that's the form of the quadratic equation. Now, you can just plug in the numbers and see that, okay, x is equal to, I think the answer here is about 0.100 meters, or x equals negative 0.08 meters. So there are two solutions. However, which of this is the physical one? Alin dito yung physical?
Yung positive.
Yung positive, because again, naglagay tayo ng negative sign dito. If I use the other approach written in the annotated lecture slides, what we need is the negative number. But in our approach, what we need to determine is the positive number. This is extraneous, and therefore the answer is x equals 0.100 meters. Okay? Nakuha yung sagot, yung tanong?
Yes, sir.
Okay. I hope you get it. Okay?
Sir, kapag show solutions po ba, kailangan pa lang ipakita yung quadratic formula or kahit yung sa calculator na lang, sir, na equation
Pwede
solver?
calculator na lang. Basta importante na sulat niyo siya in quadratic form.
Okay, sir. Thank you po.
At least yan nakita niyo, and then you can just use your calculator. Walang issue yan. Okay?
Sir, possible solution din po ba na iset as 0 is yung na compress na?
Okay. That's another, that it's also possible. However, kaya hindi ko yung ginawa kasi if I set this to be my 0, actually, wala namang change eh. Mangyayari lang, this is my y. So let's say this is y prime equals 0. So the initial potential energy of the box becomes y1 plus some x. So I have a y1 plus x, tapos yung x lilipat lang sa kabilang side ng equation. Pwede naman. The answer will still be the same. Again, for gravitational potential energy, arbitrary naman kung saan y equals 0. But for this particular problem, I find it easier to set the y equals 0 at the platform. Okay?
Thank you, sir.
Okay, again. Thank you for these questions, okay? Okay.